the external force when you apply on the solids, it causes a deformation, and the force what you apply will be said as deformed force. This object is undergoing deformation when an externally deformed force is applied on a solid object. Okay, so this kind of a procedure is said to be a deformation. Plasticity means once you change its shape, it will never regain back. Okay. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 1 of chapter 9, that is Mechanical Properties of Solids. So in today's class, let us give some introduction regarding the solids and what is the what force is acting on the solids, because of which it shows few characteristics. So now let us talk about solids. So here the solid is the one which is having atoms as well as molecules which is closely packed. That is, it is tightly packed such that the particles are not free to move from one place to the other. So in order to change the shape of the solid, either we will have to give a compression effect, or else we will have to bend the solids, or else some external force is said to be applied on the solid so that its shape will be altered. Solids are the one which is having definite shape as well as definite size and volume because of its closely packed molecular structure. Okay, so solids, if it has to change its shape, we have to give some external force to it. So that external force causes something called as deformation. So the external force when you apply on the solids, it causes a deformation, and the force what you apply will be said as deformed force. So this is all about solids. So let us now study about the deformation. So when an external force is applied, so when an external force is, this is the force, finger is exerting a force on a ball. So when an external force is applied on an object, the object which is at rest, it undergoes some deformation, that is change in its shape. Again, it got back to its original position. So, whenever an external force is applied, that force, in order to deform the shape of an object, is said to be deforming. This procedure is known as deforming, and this, wherein the solids are changing its shape due to the external applied force, that is deformed force. This is said to be a deformed force. So, this object is undergoing deformation. This object is undergoing deformation when an externally deformed force is applied on a solid object. Okay, so this kind of a procedure is said to be a deformation. So, whenever you apply deformed force on an object, it undergoes change in shape and it comes back to the original position. When it comes back to the original position after undergoing change in its shape, such concept is called as elasticity, as well as the other contrary to that, whenever you change the shape of a solid and it doesn't regain its shape back to the original form, then such kind of a property is called as a plasticity. Okay, so there are two properties of a body. One is elasticity and another one is plasticity of a object, that is a solid object. So there are two types of properties of solid. One is elasticity as well as plasticity. So now let us go to elasticity. Suppose you compress, for example, I have taken a spring over here. So if I compress a spring and leave it, what happens? That the shape of a solid changes, that is, the compression is taking place over here, okay? And when you relieve it, what happens to the spring? It comes back to its original position. Such kind of a property is said to be elasticity, and the body which possess the elasticity property is known as elastic material. The body which possesses such kind of a property, that is regaining its original position after deformation, that property which is possessed by certain bodies is said to be a elastic material. So it is like elastic material which is same as that of the stretching of the spring. So there is a restoring force, okay, which restores its original position. So suppose I have discussed about the spring. Whenever you fix a block over here which is of certain mass, what happens? The spring stretches. When you remove, that is the external force is removed, what happens to the spring? It comes back to its original position. So there is a restoring force. Pull the spring and leave it. It restores back. Correct? So this is an example for elasticity, the property called as elasticity. Okay, such kind of a material which possesses the property elasticity is said to be elastic materials. Now on the contrary to that, let us study regarding the plasticity. So here plasticity means once you change its shape, it will never regain back. Okay, for example, you can consider a clay making petty or mud. Okay, so now here the plasticity means change in its shape, but it will never regain its original position. That is all about your plasticity. So I hope you're clear with deformation, deformed force, elasticity as well as plasticity. These are the properties of a solid. So solid, once it undergoes deformation, to come back to its original position, there is a restoring force which is affecting the deformed force, which will be equal in magnitude but it will be opposite in direction. So suppose if you give a deformed force, what happens? The object which is present, it gives certain restoring force backwards. So opposite direction but equal in magnitude, because of which you can say the object has regained its shape. That is all about your elastic materials does that. But plastic materials, that is plasticity property is produced in such kind of a material, that means there is no proper restoring force, because of which it doesn't restore its property back again as that of the original one. So now let us go to the elastic behavior of the solids. So you know the solids are the one which is closely packed, okay, and the closely packed nature is due to certain force between two atoms. So suppose your solids are, if this is a cube what you are considering, here the solid molecules or atoms are present over here, which are so very tightly packed, because of which there is no movement of the molecules within the object. So there is certain force of attraction between these two molecules which is present over here. Between the two molecules, there is certain force of attraction. That force of attraction is said to be, either this part is called as molecules or it is also known as atoms. So it is between, the force lies between the atoms or molecules. So it is termed as intermolecular forces or interatomic forces. Okay, this is termed as interatomic or intermolecular forces. Okay, these are the two terms what you can give for the force which is acting between two molecules or the atoms within a solid, because of which the atoms or molecules are closely held. That is, it is tightly packed and it is held, because of which the molecules or the atoms doesn't move freely. Okay, so that is all about the elastic behavior of the solid. Once you apply a deformed force, if the deformed force is applied, its configuration will change. For a moment of time, its configuration will change and it regains back. It is restored back. That is, its shape is restored back, because of which you can say the solids has got the elastic behavior. Solids has got certain elastic behavior. The property which is responsible for this elastic behavior is elasticity. Okay. So next is the stress. You all know what is stress. So there is some external pressure which is applied on a object. So suppose if this is a object which I am considering a solid object, and there is an external pressure which is acting, external pressure which is acting on an object. Okay, so the stress, that is the external pressure, is said to be a stress which is imposed on the object. Okay, so what is that stress? Stress is nothing but the external pressure you are applying on an object such that the object undergoes deformation as well as it regains its position, that is original position. Okay, so there is a deforming force which is applied on an object, because of which it undergoes deformation and again it comes back, that is it is restored back. So there is an internal restoring force. Okay, so stress means the internal restoring force developed per unit area of a solid body. So, whenever you apply certain stress, whenever you apply certain deformed force on an object, the object undergoes deformation and gets back to its original position, that is, it is restored back. So, it is that restored force is said to be the internal restoring force. So, the internal restoring force which is developed per unit area of a solid body is said to be a stress. Okay, so now you have got per unit area of a solid body, that is solid deformed body, is said to be the stress. So now you have got types of stress. There are three types of stress, that is longitudinal stress, or it is also called as normal stress. Next will be hydraulic stress, and the third one is said to be a tangential stress. So here in the case of longitudinal or normal stress, normal means you all know it is nothing but the perpendicular. So normal stress is a stress which is acting perpendicular to the surface. So longitudinal or normal stress is a stress which is acting perpendicular to the surface of the object. So under this you have got two types of stress, that is tensile stress as well as compressive stress. So tensile stress is a stress where there is change in length, as well as compressive stress is also a stress where there is change in length. Okay, so tensile stress, there is change in length. Here also it is the same thing, that is change in length. But when a deformed force is applied perpendicular, deformed force is applied perpendicular to the surface of a solid, this is a deformed force which is applied perpendicular to the solid, the restoring force per unit area is said to be longitudinal or normal stress. Two types, tensile, compressive. So tensile is nothing but which depicts the change in length. Compressive is also the one which depicts the change in length. So change in length means in tensile stress it increases. There is increase in the length of a solid once it is deformed. What happens to the length of the object? The length increases. That is that there is a change in length wherein the length increases. Such kind of a stress is said to be tensile stress. Okay, so compressive stress. So what is meant by compressive stress? Here, whenever you give a deformed force which is acting normal to the surface of an object, the restoring force which is acting per unit area is said to be the normal stress, and under that you have got compressive stress. So what is this compressive stress? During that restoring force there is change in length, and that change in length is given as it decreases. The change in length is said to decrease, because of which you can term that kind of a stress as compressive stress. So I hope you are clear with longitudinal as well as normal stress. Now you have got hydraulic stress. So hydraulic stress is a stress wherein you have got your object, and here the deformed forces are acting equally on the external part of the object. So the externally applied deform force are acting equally at all the sides, not only in one side. It has got equal application of the external deformed force. Okay, so what happens to the object? It changes its volume. So from here to here there is change in volume. Such kind of a stress is said to be a hydraulic stress. That is the total external force which is acting on an object in order to undergo the deformation in an object, that is a solid object. So next we are going to tangential stress. So what is this tangential stress? That is the deformed force is acting tangent, that is tangential way for the object, that is a solid object. Suppose you're considering a rectangular object over here and you're just exerting certain force. Let the rectangular object named as AB as well as C and D, and suppose you're applying a tangential stress to it. It will be fixed at the base but it moves at the top. So this is the final position. So this becomes D dash, this becomes C dash. Okay, but the bottom, that is the baseline, will be fixed for a rectangular. Such a force, that is, I'm just pushing this rectangular cardboard the other way, wherein the shaded part is the final position of the rectangular object, wherein I can say that it is a tangential stress. So the deformation force which is acting tangential to it, such that there is a restoring force per unit area, and that restoring force is said to be the stress which is known as tangential stress. In a tangent way, the force is applied on an object. Here, normal stress, that is perpendicularly, that is for 90-degree, perpendicular means 90 degree, the deformed force is applied on a surface of the object. Hydraulic, all the sides equally the deformed force is exerted for hydraulic stress. So now you got to know stress as well as types of stress. So suppose you have got a stress. So what is that stress? Stress means restoring force per unit area. So restoring force which is given by F per unit area. So this is the formula for the stress, and its SI unit will be, the force is termed in Newton, and area means it is length into breadth, so it will be meter square. So it is meter minus 2. That is meter minus 2 is the SI unit of Newton meter minus 2 for the stress. Okay, so what will be its dimension formula? You have got your dimension formula as MLT minus 2 for the force divided by area is nothing but length into breadth, so it will be L square. So here you have got ML minus 1 T minus 2. This can be your dimension formula for the stress. So having this, let us go to strain. So what is that strain? Strain is nothing but the change in configuration. The change in its configuration when a deformed force exerts strain on a body or an solid object. So the configuration, the internal configuration changes when there is a external deformed forces acting upon an object, because of which there is a stress which is given to an object and the configuration changes, which is said to be a strain. So I hope you're clear with the strain, what is meant by strain. So strain is said to be a dimensionless quantity. It is dimensionless quantity. Strain doesn't have any sort of dimensions, but strain has got three types of strain, wherein you can see longitudinal strain, volume or a bulk strain, as well as shearing or shear strain. Okay, so when there is a change in its configuration, there is a change which takes place. Either the length will change, or else its shape will change, or else its volume will change. Okay, these are the changes which undergoes when the stress is applied on an object. Either the length changes, or else its volume changes, or else its entire shape changes. Okay, so here when you talk about longitudinal strain, it is change in its length to the original length. So what is that longitudinal strain? Or it is also called as change in its length, longitudinal length. Okay, so that is change in its length to its original length. Ratio of change in length to its original length. Ratio means this division is said to be a ratio to the change in length to its original length. Now when you go to the volume or a bulk strain, it is like there is change in its volume. So you can give it as ratio of change. This delta, the triangle shape, represents the change, or it is also called as delta. Okay, it represents change in volume with respect to the original volume. So this is the definition as well as the formula for types of strain under that for volume strain. Next, let us go to the shearing or a shear strain. So here, this is with regard to the shape. So there is a change in shape, that is the perpendicular lying object, the perpendicular thing. The plane which is normal changes, that is it changes its direction, it changes its angle. Okay, so here shearing or the shear stress means it is the ratio of relative displacement of one plane to its distance from the fixed plane. Okay, so there is change in shape. How the change in shape occurs? That is, its displacement changes. Its displacement, that is, if suppose the perpendicularly lying plane is present, it changes its angle theta. Here it is 90 degree. When the deformed force is applied, it changes its perpendicular way. That is, it changes its angle. It won't be 90 degree, it will be some other angle. So that is all about your shearing stress or a shear stress. So what is it? Ratio of relative displacement of one plane to its distance from the fixed plane. Okay, so that is all about your types of stress. Under types of stress, you studied about longitudinal stress, bulk or the volume stress, shearing or a shear stress. So I hope you're clear with the stress as well as strain. So having this stress as well as strain, we have to introduce a law called as a Hooke's law. He has given a law that states that you know what is stress and you know what is strain. So these two concepts are there in your mind, correct? And there is a limit. That limit is said to be a elastic limit. So what is this elastic limit? Elastic limit means it is the upper limit, that is the maximum limit. Okay, so it is a maximum limit until which the body shows a elastic property, that is elasticity. After which it doesn't show elastic property but it shows plasticity. Understood? So here it is a maximum limit for which a body can regain its shape. Such kind of a limit is known as elastic limit. So limit in elasticity. Understood? So next it is Hooke's law. So Hooke's law is like within the elastic limit. So it lies only within the elastic limit. He has given a law which lies only within the elastic limit, and elastic limit is nothing but it's a maximum limit until which even if you apply certain force, it regain its shape back. But after which if you apply the force, that is deformed force, it doesn't regain its shape again. Okay, so within the elastic limit, the stress is proportional to the strain. The stress is proportional to the strain. So that is all about your Hooke's law. So you can just give it as stress is proportional to strain. So if the stress is increased, even the strain increases. That is all about your proportionality term. Okay, if this increases, this increases. If stress decreases, strain decreases. So when you take out your proportionality, it becomes which is equal to, you get a proportionality constant K and multiplied with the strain. So where K is said to be the modulus of elasticity. Okay, so this is one of the important law given by Hooke. So Hooke's law means within the elastic limit, the stress is proportional to the strain. So that is all about your Hooke's law, and below you have got the equation for the Hooke's law expression. So in today's class, we have studied the introductory part of the solid. What is this solid? And then we have studied regarding the elasticity as well as plasticity. What is meant by deformation and how the deformed body looks, and what is the deformed force. And having the elasticity and plasticity concept, we have given the stress as well as strain. So types of stress and types of strain, its dimensions, and having the stress, strain as well as elastic property, that is elastic limit. Having these three concepts, we just introduced a Hooke's law. So you all got to know the whole concept which we had discussed in this session, that is session 1 of chapter 9, that is mechanical properties of solids. So let us all meet in the next session. Until then, have a good day. Thank you.